Hello everyone and welcome back. Today we will be doing lesson 2.1 which covers ratio and proportions. We will be talking about ratios and proportions in the later part of the transformations unit when we talk about dilations in the regular geometry class. So I want to go ahead and give you a preview of ratios and proportions so you'll know what to do when we get to it in the regular geometry class. Looking at the lesson 2.1 sheet, we first see that a ratio is defined as a comparison of two numbers. A ratio can be expressed in several different ways, and it gives you some of them. It could simply say 1 to 2, or 1 and then there are two dots, and that's just read as a 1 to 2 ratio, or 1 over 2 as a fraction. In this example, the ratio means that for every one of the first item, there are two of the other items. So just as an example, say your first item is a Coke and your second item is cookies. For every one Coke that you would have two cookies. So if you had 5 Cokes, you would have 10 cookies. That's all a ratio means. Next, it defines a proportion as expressing the equality of two ratios. Equality just meaning that it creates an equation between two ratios. It says to cross multiply to determine if the two ratios are equal. And so what we're going to be asked to do on these problems is to cross multiply to check each proportion to see if it's a true equation and that it works. And we will do that by cross multiplying and making sure the work is true and valid. So let's go ahead and look at our first example. Our first example has 1/2, 1 over 2, equals 3 over 6. Now, if you're really good with fractions, you may already be able to look at this and tell if it's true, but let's actually do the work and see if it comes out to be a true equation. So the first thing we will do is we will cross multiply 1 by 6. Notice 1 is at the top of the first fraction and 6 is at the bottom of the second fraction. We will then cross multiply 2 by 3. Notice that 2 is in the bottom of the first fraction and 3 is in the top of the second fraction. When we go across, we match up a top with a bottom and a bottom with a top. Now that we have cross multiplied, we have 1 times 6 equals 2 times 3. We actually need to do that multiplication, and 1 times 6 is 6, and 2 times 3 is 6. So 6 equals 6 is a true statement, so this proportion is true. So the directions say to write T next to the proportions that are true. So we are going to write T in the blank. Now looking at the rest of some of these other problems, you will see that not all of them are set up as a fraction equals a fraction. For example, on 2a, we have a ratio of 4 to 9 equals 9 to 4. We need to write this as a fraction equals a fraction, and that will be 4 over 9 equals 9 over 4. That's all you have to do to write it as a fraction. Once you've written it as a fraction, you will work it out exactly like we worked out number 1. Match the top to the other bottom and the bottom to the other top. In this case, it gives you 4 times 4 equals 9 times 9. 4 times 4 is 16, and 9 times 9 is 81. This is not a true statement. 16 does not equal 81, so we will write an F for false in the blank. The last one I want to look at together is 2C. This one says 2 to 5 equals 5 to 12. This is written out in words, but we want to write it in a fractional format, except we first need to write it in a ratio format. So 2 to 5 is 2 dot dot 5 equals 5 to 12 is 5 dot dot 12, which can then be rewritten as 2 over 5 equals 5 over 12. You will then repeat the process of cross multiplication to show that this gives you a true statement, or it may not. Now I would like you to finish the remaining examples on this page. Thanks for watching this video and completing the homework assignment. Remember, if you have any questions, please do not hesitate to ask, and I will do my absolute best to help you.